Hi guys, let's look at the next question. The next question that we do is question number 20. Area of shaded portion in this given figure is 770 square centimeter. Circumference of the outer circle is 132 centimeter. Find the width of the shaded portion. Perfect. So we know area is outer circle will be pi capital R square. So pi R square minus the area of the small circle, which will be pi R square, is given equal to 770. So that's one thing which is given. And circumference of the outer circle, which means circumference would be 2 pi, since it's the outer circle, which means capital R, is given equal to 132. So let's see if we can calculate R from here. So that's my equation 1, that's my equation 2. So this would be 2 into 22 upon 7 into capital R is 132, which means R would be equal to 132 into 7 upon 22 into 2 centimeter. This is 22 1, 22 6, 2 1, 2 3. Therefore, R would be equal to 3 into 7, that's 21 centimeter. So the capital R, which is the radius of the outer circle, is 21 centimeter. So put R is equal to 21 centimeter in equation 1, and let's see what we get. So equation 1 is pi times R square minus R square is equal to 770, which means 22 upon 7 multiplied with R square minus R square, which would be R plus R multiplied with R minus R is equal to 770. This is, I don't think it will help me much. So this is 22 by 7. R square is 21 square minus small r square is equal to 770. 21 square, that's 441 minus r square would be equal to 770 into 7 upon 22. Doing cross multiplication, so this is 11 into 2 and this is 11 into 7, 70. So this is 490 upon 2, which is 245. So r square 441 minus small r square is equal to 245, which means 441 minus 245 would be equal to r square, which means r square is equal to 196. Perfect. So r square is 196, which means r is equal to plus minus 14 centimeter. Since radius can't be negative, therefore r is equal to 14 centimeter. Perfect. So the small radius is 14 centimeter, the big radius is 21 centimeter. What's the question? Find the width. So the width would be, this portion would be capital R minus small r. Therefore, width of shaded portion is 21 centimeter minus 14 centimeter, which is 7 centimeter. So highlight the answer. Very interesting question. I hope you realize rough diagram, understanding the question, and not getting into complicated calculations are important aspects. Perfect. Let's look at the next question. The next question that we'll do would be question number 21. The cost of fencing a circular field at the rate of 240 per meter is rupees 52,800. Also, we are fencing a circular field, which means we are looking at the perimeter, because we will be putting the fencing along the perimeter, and the cost is 52,800. Now we need to, the field has to be plowed, which means the area has to be calculated, and that will give us the cost of plowing. Perfect. So we know the cost of fencing, so let's use that cost to calculate the perimeter. Perfect. And from the perimeter we'll calculate radius, and from radius we'll calculate area, and from area we'll calculate cost. Let's just write that down. So rupees 240 is cost of 1 meter. Correct? Yes, 240 per meter. Therefore, rupees 52,800 is cost of how many meter? This is nothing but unitary method. So this would be 52,800 into 1 upon 240. So 0 and 0 gets cancelled. Let's try and multiply. Let's try and divide. So that'll be 8 into 3. This is divisible by 8, yes. Because 6 8s are 48. That's 48. So 6 8 6 are 48. And then 0. 3 into 1, 3 into 2, 3 into 2, 0. Therefore, circumference of field is 220 meter. So we've calculated one thing, which is circumference of the field is 220 meter. This circumference should help us find the radius. So 2 pi r is equal to 220 centimeter, which means r would be equal to 220 into 7 upon 2 into 22. 22 1, 22 10, 2 1, 2 5. Therefore, a radius of field is 35 centimeter. 5 into 7, that's 35 centimeter. So I've got now the radius. Next, we need to calculate the area, because the cost of plowing the area is 12 rupee 50 paisa per square meter. Okay, therefore area of field would be equal to pi r square, which in this case is 22 upon 7 into 35 into 35 square meter. Why did I write centimeter? Yes, my mistake. This should be meter. We talk about area of a field. Perfect. So this is meter, and this will be square meter. 7175. So this is 22 into 5 into 35, which is 110 into 35 square meter. So this is the area of the field. Now we know that 12 rupee 50 paisa is cost of 1 square meter, which means what will be the cost of these many square meter? Now we'll have to multiply. So let's just multiply. Okay, cost of 1 square meter is rupees 12.50. Therefore, cost of 110 into 35 square meter is 110 into 35 into 12.50. Remember, money has to be written in 2 decimal places. Now we'll have to multiply, so let's just multiply. So it'll be 35 into 11, that's 5353. So this is 385. And now I have to multiply 385 with 125. So 385 multiplied with 125, 5 into 5, 25, 40 and 2, 42, 15 and 4, 19, 500, 900, 1925. Perfect. 2 5s are 10, 8 2s are 16 and 1 17, 2 3s are 6 and 1 7, 600, 770. That's also fine. And this is 583. So this is 5 2 9 plus 7 16, 16 plus 5 21, 8 2 10, 17 and 1 18. This is 48125. So this is equal to rupees 48,125. This is 125 because I've taken one decimal away from here. Perfect. So let's just write the final answer. So my final answer would be, therefore, cost of plowing the field is rupees 48,125. So first we calculated the perimeter from the perimeter of a circle, in this case a circumference. From the circumference we calculated radius, from radius we calculated area, and from area we used unitary method to calculate cost of plowing the land. Perfect. Let's look at the next question. The next question that we're doing is question number 22. So two circles touch each other externally, okay, and the sum of their areas is something, distance between their center is something, find the radii. Okay, so this is circle 1 and let's say this is circle 2 and they touch each other externally. That's the basic rough diagram of this question. Let the radius of one circle be small r, let the radius of the other circle be capital R. Right? So, and small r plus capital R is given equal to 10 centimeter. This is 10 centimeter. So we've got basic idea of the question. Let's see what we have. Okay, so let radius of circle 1 be r centimeter and radius of circle 2 be capital R centimeter. So what is given is therefore small r plus capital R is equal to 10 centimeter. That's my first equation. Let's see how will this help us. Next, it says sum of their areas is 58 pi square centimeter, which means pi small r square, which is area of this circle, plus pi capital R square, which is the area of the bigger circle, in this case is given equal to 58 pi. Let's take pi common from both sides. So this is pi r square plus r square is equal to 58 pi. Pi and pi on both sides gets cancelled, and I have my second equation, which is r square plus r square is equal to 58. That's my second equation. Let's look at how do we reach from here to here, because I know the value of r plus r. If I remember correctly, my chapter which was on expansions, I can square both the sides of 1. Let's see how will it help us. Okay, so squaring both sides of 1, I get r square plus r square plus 2 small r capital R, right? This is x plus y whole square is x square plus y square plus 2xy is equal to 10 square, which is 100. R square plus r square is given equal to 58. So put small r square plus capital R square is equal to 58, and we get 2 small r capital R is equal to 100 minus 58, which means 2r small r is equal to 42, which means small r multiplied with capital R is equal to 21. Let's see if this will help us get anything. Okay, I can put this in the second equation and see what this gives me. So small r is equal to 21 upon r. Right? So put r is equal to 21 upon r in equation 1. Okay, and what we get is 21 upon r plus r is equal to 10. Let's take LCM. This becomes 21 plus r square upon r is equal to 10, which means r square plus 21 is equal to 10r, which means r square minus 10r plus 21 is equal to 0. Now I have a quadratic equation. I need to find factors of 21, the sum of which is negative 10. So that's 7 and 3. So r square minus 3r minus 7r plus 21 is equal to 0. Let's group it like this. R minus 3 minus 7 times r minus 3 is equal to 0. R minus 3, r minus 7 is equal to 0. Therefore, r is equal to 3 centimeter or r is equal to 7 centimeter. So when r is equal to 3 centimeter, small r is equal to 7 centimeter, or when r is equal to 7 centimeter, small r is equal to 3 centimeter. Perfect. Find the radii of the two circles. So the radii of the two circles is 3 centimeter and 7 centimeter. Therefore, radii is 3 centimeter and 7 centimeter. Perfect. Interesting question where we found two equations and we solved them simultaneously. Good. Let's look at the next question. The next question that we are doing is question number 24. Now, This question requires a concept which we haven't done yet. That concept is in the chapter circles. So let's just look at this concept first before I solve this question. So if this is a circle and let's say I am drawing a diameter of this circle. So my radius of this, the center of this circle lies somewhere on this diameter. Let's name this AB, the diameter, the center is C. The property of circle is any angle subtended in the semicircle. Subtended would mean that it is being formed by the two edges of the chord, in this case the biggest chord, which is a diameter. So any angle made in a semicircle is always a 90 degree. So let's call this point D. Angle ADB will always be a 90 degree angle. Let's look at a different kind of an angle. If I have an angle like this, which means if I have a line like this, and let's call this point E. Since this is being made in a semicircle, angle AEB will always be 90 degree. Let's look at a third kind of an angle. Let's say if I have an angle like this. Any angle in a semicircle will always be 90 degree. So angle AFB is also 90. So the property is angle subtended in a semicircle is always a right angle. So that's a property that we would be doing in the chapter circle, but this next question requires us to use that property. That's why I am introducing this property to you now. So I repeat, any angle in a semicircle, angle subtended in a semicircle is always 90 degree. Now that we've done this, let's look at this question. It says a square is inscribed in a circle of radius 7 centimeter. Perfect. So this is a square which is inscribed in a circle of radius 7 centimeter. Perfect. So done. This side, this side, this side, and this side are equal. In this case, this is A, B, C, and D. This is 90 degree. This is 90 degree. So join AC. Number one. Number two, since angle ABC is not ABC, yeah, ABC is 90 degree. Why is it 90 degree? Vertex angle of a square. So since angle ABC is 90 degree, therefore AC is the diameter of the circle. So now we know that AC is definitely the diameter of the circle. Why? Since angle subtended in a semicircle is a right angle. So since this is an angle which is being subtended in this semicircle, that's why it is 90, but this is the reverse of it or the converse of it. So angles which is 90 degree is subtended in a semicircle. So AC is my diameter. Next, we need to find the area of the square. We know area of square, let this be x, this be x, this is x, this is x. So area of square is equal to x square. Perfect. How do we find the diameter? How do we find the value of x? Well, diameter is 7, which means radius is 7, which means AC is diameter is equal to 14. So AC is equal to diameter is equal to 2 times radius is equal to 14 centimeter. We know diagonal of a circle is equal to x root 2. Again, using Pythagoras theorem, diagonal of a right triangle is equal to x root 2. In this case, x root 2 is equal to 14 centimeter, which means x is equal to 14 upon root 2 centimeter. Area of square would be equal to x square. In this case, 14 upon root 2 multiplied with 14 upon root 2. That's 14 into 14 upon 2. 2 1 2 7. That's 70 and 28. That's 98 square centimeter. Perfect. Very interesting question. Requires a lot of concepts. Concept 1, angle in a semicircle is a right angle. Concept 2, it needs you to figure out the value of the first. You need to figure out that the AC is a diagonal. Next, you will figure out that the using Pythagoras theorem, the diagonal of a the diagonal of a square or the hypotenuse of a right angle triangle is x root 2. And that's about it. Not diagonal, this is hypotenuse. My mistake, this is hypotenuse. Hypotenuse of an isosceles right angle triangle, or I can write this as diagonal of a square. My mistake. This is diagonal of a square is x root 2, or hypotenuse of a isosceles right angle triangle. Perfect. Let's look at the last question of this exercise. In fact, now that we've just done 24. Question 23 is your homework, and question 23 also uses the same property of a semicircle. Angle subtended in a semicircle is a right angle. So in that question, we're talking about a rectangle. So you should solve that question on your own. Let's look at the last question of this exercise that we solve, which is question number 25. Question 25 says, a metal wire when bent in the form of an equilateral triangle of largest area encloses an area of 484 root 3 square centimeter. So this is equilateral triangle ABC, and the wire is being bent in the form of an equilateral triangle. Let each side be x. We know area of this is 484 root 3 square centimeter. So we know area of an equilateral triangle is equal to root 3 upon 4 into side square, in this case x square, and this is given equal to 484 root 3. So root 3 and root 3 gets cancelled, which means x square is equal to 484 into 4 square centimeter, which means x would be equal to square root of this. 484 is 22. The square root of 484 is 22. Square root of 4 is 2. Therefore, x is equal to 44 centimeter. So each side of this equilateral triangle is 44 centimeter. Therefore, length of wire is equal to basically the perimeter of this equilateral triangle. So perimeter of triangle, which is 3 times 44 centimeter, which is 3 to 44, 120 and 12, that's 132 centimeter. So basically the wire which is being used is 132 centimeter long. Right? So now that we know the length of the wire, it says if the same wire is bent into the form of a circle of largest area, find the area of this circle. So now I have a circle, the perimeter of which in this case circumference is 132. So 2 pi r is given equal to 132. We need to find the r, and when we find the r, we will get the area also. So 2 into 22 upon 7 into r is equal to 132, which means r is equal to 132 into 7 upon 2 into 22, 11 2, 11 1, 11 2, and 2 6, 2 3. Therefore, r is equal to 21 centimeter. So the area of this, the radius of this circle would be 21 centimeter, and the area would be equal to pi r square. In this case, 22 upon 7 into 21 square centimeter. So 7173. So that's 66 into 21. That's 6, 6. This is 2 6 are 12. 2 6 are 12 and 1 13. So this is 6831. So this is 1386 square centimeter. Therefore, area of required circle is 1386 square centimeter. Perfect. That brings us to an end of this exercise. Let's look at the homework question. The homework question would be question number 19 and question number 23. Two questions, like I said earlier. Question 23 involves the circle property. It says angle subtended in a semicircle is a right angle. Thank you so much. Take care. Be safe. I'll see you with the next video. Bye bye.